Good afternoon, everyone. All of you have joined the meeting. Okay. So last two lab I was not able to take earlier. The on 26th it was holiday, and in last lab I was out station, so I was not able to take the lab. So today we will be having our third experiment. वही attendance हो गई थी ना last time. Last lab की attendance हो गई थी ना.
Yes, ma'am.
Okay. So your third experiment is fatigue testing of standard specimen on servo hydraulic universal testing machine. Okay. So in earlier two experiments we have seen that how a tensile test is performed on universal testing machine. Okay, so tensile test means it is a uniaxial loading condition. We just apply a tensile load on the specimen and we find its fracture strength, we find its UTS, and we have also seen the graph for this, for the two materials, mild steel and the aluminium. Okay, but the fatigue loading, are you aware of this fatigue loading, cyclic loading? Have you read about it? Have you read about this fatigue loading and cyclic loading? Okay. So in fatigue loading, what happens is a cyclic load is repeatedly applied on the specimen, and the material can fail below the yield strength also, because and that is called the endurance limit of the material. Okay, so these all concepts we will see in today's lab. So now you have to actually make a file, lab file, and in that you have to write down the aim and apparatus and this procedure and results of the experiments. So for last two also you try to write down these things. अभी कॉलेज ओपन होने का हुआ है क्या तुम्हारा? कुछ कॉलेज से नोटिस आया है क्या बीटेक के लिए? अभी नहीं आया है. ओके, तो वीडियो ही देख लेते हैं अभी इस वाले में भी. अदरवाइज apparatus तो apparatus are there in college. So I have to teach through video only. Yeah, so you have to write a lab manual type of thing. You might have written in earlier classes also, no? In earlier semesters also you have written the lab manual. In that way only you have to write down. Sharing my screen now. Is my screen visible? Is my screen visible to all? Okay. So here we can see that this is a theory part of the fatigue. So this is a cyclic load. Okay, so we have S denotes the stress. So this is the maximum stress level and this is the minimum stress level. So when we apply the cyclic load to a material. Cyclic load means this complete thing. This starts from zero, it reaches a maximum value, then it reaches a minimum value, and it again comes to zero. So this complete is one cycle from this zero to the next zero. Okay, so this is one cycle and this is two cycles. So if on a specimen we apply the cyclic load, so these are the number of cycles. It can fail, the material can fail due to this cyclic load for after a certain number of cycles applied. So the number of cycles is noted by n. So this is a kind of SN curve, you can say, and this we plot through experiment. This is a generalized form just to demonstrate the purpose of this, and for the experimental purpose we will see a video now, and in that video we can see the how the cyclic load is applied on the material, and how the material reaches its maximum stress value, and then it fails. Okay, so so this line you can see that even if the material when a material is subjected to cyclic loading, it fails after certain number of cycles. Okay, even if the load is much lower than its yield strength. Yield strength we have seen in the last lecture that sigma y was the yield strength in the graph in the stress strain curves we have seen in last lecture. Okay. That stress level below the yield strength is the endurance limit of the material. So how is it performed? I will show in video. Okay, so this is a lab setup for the fatigue testing. In this we apply a servo. We are using a servo hydraulic, a universal testing machine, in which the load is applied in a cyclic manner. Okay, so you can see this. These are the two types of load which are applied. One is the tensile and second one is the compression. Okay. So here you can see here it is connected to an actuator, and that actuator gives the tensile and compressive load in a type of cycle. So this is the setup of the this is the setup for the experiment. This is the machine frame, and the load cell is here. From here we can give the tensile and compression, and then specimen, and a spring is attached to it here, and this is how it is performed. Okay, so we are giving a cyclic load to the specimen, which you can see here. After a certain number of cycles, the specimen will fracture. Here you can see that a crack is propagating from the surface of the specimen to the depth of the specimen. Okay, so here you will observe that necking is not there, which we have seen in the that UTM of mild steel and in aluminium. There was the tensile is a load was given, and the material the cross section of the specimen was reducing and necking was there. But for fatigue testing, we can see that we have applied the cyclic load, and the crack is generated at the is initiated at the surface of the specimen, and it propagates. Okay, and after a certain number of cycles, it breaks. So you can see here that You can see here that this portion is still moving. It means that cyclic load is given here in this portion, and this portion is rigidly hold in the machine frame. Okay. After that, the specimen is removed and its fracture surface is observed. So there are two parts in the fracture surface. Okay. So first is it's a propagation. It's area. So this fracture area is the catastrophic when this is crack. So there are two things. Aim of this is just to make you understand how the cyclic load is applied and how fatigue testing of a material is done. So after this, these all actually come in fracture part of the. You are in 6th semester, so you might not have this subject. So I'm not telling you this in detail. So they have actually perform from this test. What we get is we get the number of cycles to failure, how many number of cycles of the load we are applying to the specimen before it fails. Okay, so there are n number of specimens. There are some specimens they are testing in the lab, and these are some number of specimen of the same material. So they are testing the same material specimen for around 10-12 times just to make just to get the endurance limit of the material, that is below which stress value the material will not fail even if infinite number of cycles of load is applied. Okay, are you getting it? Is there any doubt? ये समझ में आया कि फिर से दिखाना है वीडियो? Okay. So this is a stress versus time, and this just shows the type of loading we are applying. This type of loading also I think you have studied. No, these are types of variable loads, and these are three, that is fluctuating load, reversed load, and the repeated loading. These are the three types of variable loads we can apply. So this is the reverse load, and the fluctuating load might will be like this. It will be above the this level, zero level, and the repeated load will have only either tension or compression. Okay, so there are three types of loading. So in this case we have applied this reverse loading, okay, in which the tension is also there, tensile load is also there, as well as compressive load is also there, and this tensile part plus compressive part together makes one cycle. Okay, so after performing the experiment we can draw the SN curve, that is stress versus number of cycles for failure curve. Okay, so sigma A denotes the stress amplitude and number of cycles to failure is N. So as the number of cycles to failure is very large, like in the case we have just seen, in this case the specimen failed about 3 lakh cycles. Okay, 3 lakh number of cycles of load. So it is not possible to show it these much level of cycles on the x-axis. So we have plotted a logarithmic scale. Okay, so these are the values we get from the different specimen. So from specimen 1, 2, 3 and so on. So for some number of specimens they have plotted the values. for this stress, for this much amount of stress we are getting. If we apply 248 megapascal of stress, then the material will fail after 381,000 number of cycles. If we apply the 265 megapascal stress, then the material will fail after 43,600 number of cycles. Okay, so like this they have plotted the graph, and from this we can see that it is observed that below this endurance limit the number of the material will not fail even if we apply the infinite number of cycles. Okay, loading cycles. So this is how SN curve is plotted, and these are some of the practical examples of the fatigue testing. Like for cycles, the handle is um, the handle undergoes a fatigue testing. Okay, so you can see this. The fatigue testing is performed on the handle of the cycle for the sports cycle and all, because they do use in rough surfaces now. So we use this, and for second is for in aeroplanes also the wings. When the aeroplane in the wings of the aeroplane actually bears the cyclic load in the air. Okay, so its testing is also done in the laboratories. It is the cyclic loading is applied on the wings of the aeroplane. Okay, so these are some of the practical examples of cyclic loading. So okay, so is there any doubt? Last time क्या किया था for the tensile testing of tensile testing in the UTM machine, the purpose of the test was to find the fracture strength of the material. Okay, so we have plotted the stress strain curve. While for the fatigue loading, what we are doing is we are applying number of cycles of loads. So our aim is to find about that after how many number of cycles of loading the material will fracture. Okay, so and we will find an endurance limit in order to see that what on an average what amount of stress we can apply on the material so that it will not fail for infinite number of cycles. But no material can sustain infinite number of cycles. It will fail after some period of time. But maximum number of cycles it can loading cycles it can bear. So this is the endurance limit of the material. Okay, for cyclic loading. So this is the purpose of performing this fatigue testing. Okay, तो अभी कोई डाउट है इसमें? Anyone have any doubt in this? Okay, you know difference between creep and fatigue? Creep में क्या होता है? अरे आंसर तो दिया करो तुम लोग. Constant load makes failure. Okay. With time. ठीक है. तो डिफरेंस समझ में आ गया ना? फटीग में हम साइक्लिक लोड दे रहे हैं. ओके, सो okay, so this was the थर्ड एक्सपेरिमेंट. तुम्हारा लैब तो कॉलेज में देख पाओगे, प्रैक्टिकल तो अभी वीडियो से दिखा पाते हैं हम लोग. तो एक असाइनमेंट भी बोला है सर ने करने के लिए. तो असाइनमेंट में क्या है? You have to plot the SN curve for aluminium as well as for steel. Okay, and for this you will need the data points हमने अभी देखा था ना कर्व में डाटा पॉइंट्स आए थे जब एक्सपेरिमेंट परफॉर्म किया था. व्हेन दे हैव परफॉर्म द एक्सपेरिमेंट, we have got the data points of the stress and the number of cycles. So those data points you can take from either any data book, or you can take from some if someone have performed the experiment, so you can search the literature for it and take the data points from there and plot the stress strain curve, sorry, stress strain curve nahi, SN curve for the aluminium and steel. Okay. So this will be your third assignment. The first two assignment are combined. Actually, I have given earlier na your first assignment. So that is a combination of first, assignment 1 and 2, and this will be your third assignment. Okay, so this you have to do, and you have to make the lab manual, which I have already told you, with the aim, apparatus, and procedure and results. Okay. So you can take help from your seniors if any of your seniors is having any copy of the lab manual. So they can provide you, and you can see at least the aim you have, that is the uh, your experiment name is your aim, and apparatus you can apparatus is also known to you, so you can write it in the form of a lab manual. Okay. So when will you submit this third assignment? Sunday तक हो जाएगा? Will you be able to submit by Sunday or Monday? You understood what is the assignment, no? Assignment क्या करना है समझ में आ गया ना? You just have to plot the SN curve for aluminium and steel, taking the data points from either some experiments which people have performed earlier. अब सब एक जैसे ही मत करना, सबको अलग अलग डाटा पॉइंट्स निकालने हैं, ठीक है? Otherwise one will do and other will copy. Don't do like this. ओके, ठीक है, अब अटेंडेंस ले लेते हैं. रोल नंबर 1.